Good morning, dear students. Today we will learn the determinant of a matrix, especially third order. In previous class, we discussed about the determinant of a matrix second order and third order. But in previous class, we did and we saw the examples to the second order mainly. And in this class, we will discuss some more problems on determinant of a matrix and how to find the determinant of a 3 by 3 matrix. 3 by 3 means order 3, that is 3 rows, 3 columns. Let us recall yesterday's or in the previous what we learned. A 2 by 2 determinant is very easy, it is AD minus BC. And for 3 by 3 we have to take any row and using any row we have to write its determinant. Like first row, if we took the first element and it's a minor, and next put minus, because for second element we have to put minus and second element into its minor plus third element with its minor. So this summation, these three summations is called determinant of matrix. Now, to understand easily, we will see the procedure and we will find with some examples, and we will find the determinant of 3 by 3. So let us see determinants. So every square matrix is contain a unique value. That value is called determinant. And today's presentation objectives, or today's class objectives are: after completion of this period, you would be able to know cofactors. Of course, in previous class we discussed what is cofactor. Cofactor is nothing but sign into minor. The minor with the sign is called the cofactor of that particular element. Expansion of determinants. So to find the third order matrix determinant, we have to expand by using its row or column of the matrix. We can expand or we can find with any row or any column of the matrix. So what is minor or an element, or what is minor of an element? Each element has a minor. A determinant obtained by deleting row and column contain it. So, definition of cofactor. So minor means if we delete its row and column where it intersects, the remaining part in 2 by 2 the only number itself is minor, or in 3 by 3 4 elements will be there after deleting row and column where it intersects. That determinant is called minor of that particular element. So cofactor means, cofactor is also a, we can give each element have cofactor also, minor also and cofactor. So cofactor of an element equals to minus 1 whole power I plus j into minor of element. Simply we can say this positive or negative sign with minor is called the cofactor of particular element. So we can easily put signs by observing. If it is first row first element, that is plus, and besides that they will come with opposite sign, that is minus, and against side if we observe that it is positive sign, like this plus minus plus, minus plus minus, plus minus plus. So we can fix the sign by using minus 1 whole power I plus j. Here I is a number of row where the element is, and the number of column is represents with j, where I equals to row number containing the element and j equals to column number containing the element. Here suppose we want to know about B2 element cofactor. Here B2 is located in second row, therefore row number I equals to 2 and column number is j equals to 2 for B2. Cofactor of B2 equals to minus 1 whole power 2 plus 2, and intersection of row and column of B2 where it is the remaining elements are, after deleting row and column, we have A1 C1 A3 C3. So find that determinant is A1 C3 minus A3 C1. So here we have the positive sign, minus 1 whole power 4 means even means plus. Or we can say directly B2 is in the second row, first A2 is have negative sign, then its side B2 means it is a positive sign with minor. So we can say directly, if A1 is positive, if A1 is surely positive, so A2 is negative, then A2 beside B2 is there, so B2 is positive. Definitely opposite, side element is behave like a opposite sign. Next, see one example. The matrix is here given 1 4 7 2 5 8 3 6 9, or we can say two parallel lines. Sometimes it is a determinant of the matrix, but here we are discussing cofactor of 4, so consider it as a matrix. I already told you in previous class, here two parallel lines sometimes expressing to show the matrix, and sometimes it is taken also for determinant. So here the priority is given for cofactor, so it is we can consider as a matrix symbol. So cofactor of 4 is equals to, 4 is located in first row and second column, so I is 1 and j is 2. So minus 1 whole power I plus j means 1 plus 2. After deleting row column where intersected at 4, remaining elements are 2, 8, 3, 9. So determinant is 2 into 9 minus 3 into 8. Minus 1 whole power 3 means negative symbol. that is minus 1. 1 we need not to be right, because 1 into something something, and we can say directly the 1 is in the first row, first element is positive, then its beside element is 4 has a negative sign. To finding the cofactors, it is negative sign with its minor. So by procedure also we got minus. So minus 1 into 18 minus 24. In the bracket, if we simplify, we will get minus 6. Minus 1 into minus 6 is 6. So the cofactor of 4 is 6. Here shaded picture is where the 4 is intersected with row and column, showing in a shaded, and we are deleted that elements and taken remaining 4 elements determinant, and minor into sign is called cofactor of particular element. We will see another example. So see here example 2. Delta equal to 3, 4, 5, 6, 7, 8, minus 2, 3, minus 1. Here we can say we are finding the cofactor of 3 because the shaded part is intersected at 3. So we can say its sign is positive because at the beginning in the first row, first element is positive. By substituting in the format or in the formula, we will get positive. So cofactor of 3 equals to minus 1 whole power 1 plus 2, and 7, 8, 3 minus 1. That equals to, here the printing or the number typed wrongly, minus 1 whole power 1 plus 1, not 2, it is a 1. Here wrongly typed or wrongly printed or wrongly entered. So we have to observe here that is not 2, consider it as a 1. So 1 plus 1 is 2, minus 1 whole power 2 means positive. So the first element always in the first row is positive. Here that is not 2, j value is also 1 because 3 is located at first column. Here 2 3s are showing, but we are discussing about first row of first 3, first row and first column of this 3 element 3. If we discuss about the third row, so 3, it is not in the first row, so it is a I value is, its I value is 3. So definitely we are discussing we are finding the first row first element's cofactor, that is cofactor of 3 we are discussing. So 1 plus 1, the minus 1 whole power 1 plus 1 should be there, in place of 2 it is 1. So please correct it, and it is not minus 1, it is positive 1 plus 1, and the determinant is minus 7 minus 24 is minus 31. Here minus 31 is the answer, so here wrongly given or wrongly entered, so please correct it and note down it is a minus 31 only, not plus 31. By mistake it came and typed wrongly here, so please see this is a minus 31. Now we can see example 3 here. So we know the procedure. So if any plus minus or number mistakes are there, please neglect them, because sometimes in the typing, in the speedy, it may be wrong enter. It may possible to wrong entry. So by our knowledge or procedure or our intellect, we have to decide, is it wrongly entered or not. Now here we are discuss or will find about the cofactor of -2. See here, -2 is intersected with row and column in a yellow colored. So -2 is at the location of first row and third column. See, you can hear again the j value is wrongly entered here. That is not 2, it is a 3. So -1 whole power 1 plus 3. So unfortunately here also 2 entered, so it is actually 3 and it is a positive sign. So positive into its minor is 3 minus 1 4 5. That is 3 into 5 minus 4 into -1. Then 15 plus 4 is 19 is the answer, not -19. Please correct it and note down as a 19 only. Expansion of third order determinant. In previous class also we discussed. Now we will discuss here clearly and with examples also. We know 2 by 2 thoroughly. We know it is easy for 2 by 2 determinant. Now we will know the third order determinant. Third order means 3 rows and 3 columns. A third order determinant can be expanded shown below. Let delta equals to a1 b1 c1, a2 b2 c2, a3 b3 c3, and here we can take it as a determinant of that matrix, expanding by first row. So I already told you 2 parallel lines sometimes represent 2 matrix, and here it is not a matrix, it is a matrix determinant. It is representing its determinant. So delta equal to, here we took first row first element and its minor as a product, a1 into b2 c3 minus b3 c2, and to come to the second element we have to write its sign, that is minus into element and its minor. So minus b1, here we are minor with sign means we are multiplying with its cofactor. So we can say product of element and its cofactor. So here 3 additions, indirect 2 additions, sum of 3, its elements and cofactors, simply we can say, of any row. Here we are particularly taking first row, so that's why we are written like this. So minus b1 into its minor, a2 c3 minus a3 c, plus c1 into a2 b3 minus a3 b2. We can write in the form of this also. Delta r that equals to a1 of its minor b1 c2 b3 c3 and b1 of its cofactor. First one also we can say a1 and its cofactor and plus b1 and its cofactor. So plus into minus minus, that's why we are written here minus b1 and b1 into its minor, and similarly plus c1 into its minor. So the minor or cofactor we can represent a1 into its cofactor as a capital A1 plus b1 into its cofactor is capital B1 plus c1 into its cofactor with capital C1. So here we can say sum of its product of element and cofactors, where cofactor of a1 equals to capital A1, that equals to minus 1 whole power 1 plus 1 b2 c2 b3 c3, that equals to b2 c3 minus b3 c2. Cofactor of b1 equals to capital B1, that equals to minus 1 whole power 1 plus 2 and minor a2 c2 a3 c3, that equals to minus of a2 c3 minus a3 c2. Cofactor of c1 equals to c1 equals to capital C1 equals to minus 1 whole power 1 plus 3 a3 b2 a2 b2 a3 b3 equals to minus of a2 c3 minus a3 c2. Similarly, we have delta equals to our second row a2 capital A2 plus b2 into capital B2 plus c2 into capital C2. Expansion by second row. So we can say delta equals to or that equals to determinant obtained by removing the row and column intersecting at A1 and minus determinant obtained by removing the row and column intersecting at B1 and plus determinant obtained by removing the row and column intersecting at C1. Expansion is in respect of any row or column gives value. This is important point. And delta equals to or det equals to b1 capital B1 plus b2 into capital B2 plus b3 into capital B3. Here we are taken a column, expansion by second column. Delta equals to sum of the product of the elements of any row or column with their corresponding cofactor. This is the definition or formula we can say to find the third order's determinant. See, once again I am saying determinant of third order, that is delta equals to sum of the product of the elements of any row or column with their corresponding cofactors. Cofactor. Sum of the product of the, sum means additions, you can see the above line. Product of the elements of any row or column with their corresponding cofactor. So here we can observe the second column expansion. Sum of means we have additions. Product means we have the product of element and its cofactor. That is, we said here, corresponding cofactor. Example: find the determinant of 3, 4, 5, 1, 2, 6, 9, 7, 8. The solution is, let delta equal to, here we can say it is a det 3, 4, data 3, 4, 5, 1, 2, 6, 9, 7, 8. Expanding by R1, we have delta equal to 3 into its minor and minus 4 into 4's minor plus 5 into its minor. And we already know how to find the determinant. That is 3 into 16 minus 42 minus 4 into 8 minus 54 plus 5 into 7 minus 18. That equal to 3 into minus 26 minus 4 into minus 46, 5 into minus 11. That equals to minus 78 plus 184 minus 55. That is 51. So 55 or 78, if we add that, you can say 113 minus 113. Sorry, we can say not 113, sorry, just by 13, 6 percent. Yeah, it is a 13, it's 133. So if we subtract from 184, we'll get 51. Okay, so the determinant is the given matrix is 51. Now we will find the determinant of 3, 2, 4, 5, 3, 8, 7, 6, 1. We can easily assumption it is a direct two parallel lines, means we can here consider as a, we have to find the determinant. There is need not to mention the again determinant. Here mentioning means they are considering as it a matrix, no problem. But actually here two parallel lines we can take as a determinant symbol. So in the question they have to keep the square brackets, but we can understand it as per the convenient, as per the they are given. We can show the matrix in 3 types. So this is also one type. So let us see the how to find the determinant. Here we are expanding by C1, that is column 1. We have delta equals to 3 into its minor minus 5 into its minor plus 7 into its minor. So 3 into 3 minus 48 minus 5 into 2 minus 24 plus 7 into 16 minus 12. 3 into minus 45 minus 5 into minus 22 plus 7 into 4. That equals to minus 135 plus 110 plus 28. That equals to 135 minus 135 plus 110 means it is minus 25, and minus 25 plus 28 equals to 3. So the determinant of 3 by 3 matrix value is 3. Summary. In this class, you have learned to find the cofactors of given determinant, expansion of third order determinants. Quiz. Cofactor of an element of a determinant is cofactor of an element of a determinant is minus 1 mole power I plus j minor of element, right? Minus 1 I minus j is not, because it's I plus j, and here given second in B option j minus I, so it is not correct. And C option is given plus 1 whole power I plus j, so it is not a plus 1, so this is also not correct. Only A is correct. The D option is all above, so all above is not a right answer, only A. So that's why A is showing in a red ink, that is the A is the correct answer. So cofactor of an element of a determinant is minus 1 whole power I plus j into minor of element. Next, determinant expands of options are only one row. Only one row is only not a particular row. We can expand by using any row or any column. So B is one row, one column, not particularly one row, one column. Actually, it is any row or column, any one of. So here C, any row or any column. So C is the correct answer, but the option D is showing all of them, so D is not correct. Only C is the correct answer. Let us check. Yes, absolutely right. So C is highlighted in a red ink, that is any row or any column. To expand, to know the determinant, we will expand using any row or any column. At the end we will get the same value. Assignment. Find the determination of here determinant it is asking 3, 4, 5, 1, 2, 6, 9, 7, 8. You know how to find the determinant. Take first row, that is 3 into its minor, and next minus 4 into its minor plus 5 into its minor. So 3 into its minor means 2 8 is 16 minus 7 6 is 42. 16 minus 42 is 26, minus 26. Okay, so 3 into minus 26, that is 3 6 is 18, 3 2 is 6 7, so minus 78. And like this, minus 4 into we have to like find and we calculate, then we will get the value of the determinant. And the second question is also we can can calculate easily. The question is same. Find the determination. I mean here determinant it is. Find the determinant of 1, 2, 3, 2, 1, 4 minus 1, 4, 6. Next, another question is find the cofactor of 2. See here in the matrix 3, 4, 5, 1, 2, 6, 9, 7, 8. Cofactor means first we have to decide what sign it is with the minor. So if you see in second row, second element is with positive sign because 1 is a negative sign, or we can cross check like -1 whole power I plus j. I is a second, I value is 2 and j value is also 2. So 2 plus 2 4. So -1 whole power 4 is positive because 2 is located in second row, second column. So positive sign. And I already told you we can say directly because 3 is positive and its downward, 1 is negative, next downward, and its next side is positive. Like this way also we can decide the sign positive, and now we will find its minor. Delete the second row, second column where second is intersect. Element 2 is intersect. The remaining elements are 3, 5, 9, 8. Now 3, 5, 9, 8 minor is determinant is AD means 3 8s are 24 minus 9 5s are 45. So 24 minus 45 is minus 21. So cofactor of 2 is minus 21. For if you understand this, you can easily write the solution or steps or answer for this problem because I explained. You just put it on the paper only. Next question. Find the cofactor of -1. First we have to understand what is cofactor. Cofactor is a sign with its minor. Only sign into minor. That is called the particular element's cofactor. Here -1 is located in the first column and third row. Third row and first column. Not in the first row, third row. But column is first. So 3 plus 1 means 4. So it is a positive sign. Or we can see like this. First one is positive and second downward is negative and downward is positive. So positive sign, and -1's minor we will find, that is 2, 3, 1, 4's determinant. Data of 2, 3, 1, 4. That is 2 into 4 minus 1 into 3. 8 minus 3. 8 minus 3 is 5. So plus 5. That is 5 we can say. So this is also I explained. You just put on the paper and write neatly in your rough notes or running notes or classwork, and do the exercise problems and write in the order at fair notes so that you can know which one is missing and which one is you are getting and which one is you are not getting the solution. So this is the determinant of 3 by 3. How to find 3 by 3 matrix determinant, and I hope you got the point, because using any row or any column we can get the determinant of 3 by 3. If we took first row, the formula is sum of the product of element and corresponding cofactor. So based on this, if we do, we will get the value of the 3 by 3 determinant. So we already saw in this presentation how to find 3 by 3 matrix determinant with suitable example, and we can also see like a formula also, because generally it is expressed with a1 b1 c1 a2 b2 c2 a3 b3 c3. By expanding first row, if we remember that by using that one line, if we substitute for any 3 by 3 matrix taking first row, that is also helpful, and that is also a chance to get a value, definitely. So this is the way or procedure. If you understand, you can take any column or any row. So finally you have to remember this one sentence: the determinant of 3 by 3 is equals to sum of the product of the elements of any row or column with their corresponding cofactor. So element, cofactor means sign and its minor. And means here we have to multiply with sign to the minor. So we have to multiply both sign and its minor of the element. So if you have any doubt in the sign, you have to take minus 1 whole power I plus j format. I is a number of row and j is the number of column. So I indicates the where the element is located in the row number, or which number row it is there, and j represents the column number where it is located, the element. So I plus j, if it is minus 1 whole power I plus j, in the power, if you have an even number, it is obviously plus. And if you have odd number in the power of minus 1, then it is a negative sign. So minus simply kept if it is negative, or if it is positive, plus. 1 need not be kept. If you are kept, no problem, because 1 into something only. But in positive sign, there is no issue if you put or not, because it is implied. But whereas we get negative sign, we have to write negative, and if it is necessary we have to multiply with the minor, and after the multiplication or the product, whatever the conclusion, whatever the result, we have to put or write or calculate accordingly. Like this you can test at home. First you do with first row and find the determinant, then take second row and follow the same procedure, and then find the value and check it is same or not. If you got the determinant value by expansion